Wait, what happened?
Just be nice and patient because this, well, partly it crashes partway through, or freezes partway through. The start bit is normally kind of slow anyway. I had to try and fix up all the timer code, but this is not my demo. This is just a port of it. Yes, it is. And it's literally running in open computers. Woohoo!
Mind giving me a link to the actual demo on Linux?
Do a search for BB demo Linux or something like that. Sorry, I didn't get around. Yeah, firstly, MP3 decoding. Well, since this is partly my, alright, this is mostly my fault. I haven't updated the encoder or the PWM encoder to 1A, so the tapes just sound completely wrong, and so I couldn't demonstrate that. Unfortunately, another thing that's one thing I was actually going to do, I needed an SSL library, and the TLS library, whatever. So I had to find one, and I never got around to getting it to compile properly. So, but what I was going to do was I was going to take that. I was going to reverse engineer YouTube DL to work out how to actually grab stuff off there. I managed to write an FLV. I managed to make something to rip the audio out, the MP3 audio out of an FLV file. And I was going to try and play the audio from a YouTube video directly, but never got around to getting that working. Just mostly because TLS and stuff. Another thing I was going to try was Mesa, but unfortunately Mesa actually is notably larger than the full megs. It's something like 20. Yeah. So, and I never got around to even trying to port Doom. I have managed to port the original Doom source to use Allegro 4, but so the code's not bad, but yeah.
I like how the uncolossal chest is called what it is. When it's a super tiny chest, though, is one chest.
The uncolossal chest is really cute.
I know, right? It's amazing.
It's like...
By the way, the fact that this demo is going really slowly is nothing to do with the tick rate. This is actually genuinely this slow on a 40 megahertz MIPS with like notably high RAM read speed.
What do you expect?
It's got a proper. It's actually got the 16K/4K cache. So 16K for instructions, 4K for data.
We should totally put OpenWRT onto an Open Computer's computer and give it the ability to use Open Computer networking.
Yes.
We should totally do this.
Another thing that's unfortunate, I never quite got Linux to mount root.
Yeah,
alright, so it crashes pretty much about now. It's never managed to get past that.
Wow. Why?
Don't know. Anyway, let's shove the load disk back in. Oh yeah, fun thing. This BIOS loads static ELF files because it's static ELF files are actually really easy to load. You just traverse, you read the header, you make note of the entry points, and then you go to the program header, and anything that's a PT load section, you load it. It's pretty straightforward, actually.
Wait, is this Lua running on MIPS?
Yep, oh. This is legit.
Wait, unscribed is back?
Why did I type in done? Oh, that's right. That's Spawn Shell. I have a Mandelbrot viewer, but it's not tuned for this kind of screen. You need a tier 3. Well, you need tier 3 160 by 50 resolution. Otherwise, it looks kind of ass, but it is actually on the disk. Speaking of on the disk, you can read files. I don't think this version quite had the support for writing files. Fuck, no, that does not work at all. That's not part of the file system set up. Basically, this is pretty much a Lua running on the metal. It is the only thing that there is basically a wrapper library. What are some fun things to do in Lua?
We should really make an ARM BIOS and then PIC and AVR BIOS, like the really small microcontroller.
Won't make that much. I'm mostly kind of. Oh yeah, it's got a floating point unit and an EMMU. I can't really demonstrate the EMMU in here though. I actually had a nano kernel which could legitimately, it could load Lua, and that would communicate using syscall to access the disk and stuff like that. And I could load, because of the MMU, I could load that off a tier 1 stick of RAM. So 192 kilobytes. Oh yeah, fun thing, MIPS is easier to emulate than ARM, which is easier to emulate than at least the Z80. Honestly, Z80 is a shit of a thing to emulate. Sangar is basically going to be writing an emulator for the 8080, which at least doesn't have the IX and IY registers, so it makes it less painful.
ARM in thumb mode should be easy to emulate though.
68k. Go talk to Bew. He's basically summed up. That one is probably the hardest CPU to emulate.
What?
Like, okay, so you've got add A, you've got add, and they're completely different. You got different ops for different things and shit like that. Fuck it, I'll run the Mandelbrot. Actually, no, because that ends up screwing up one of the variables. But yeah, this is legitimately Lua, and in fact, if you do something like this.
Is there a command to reset my, like, cybernetic stuff?
Yeah, blue screens. Fault number 7, I believe, is... Unfortunately, I don't have the unstripped ELF file on this, or any of the ELF files on this computer, so I can't actually tell you exactly where that is. But yeah, you can. If you did that with the nano kernel, it would just like it would get into a busy loop and just freeze. Just because it would run out of pages. But yeah, if you actually did boot that off a tier 1 stick of RAM using the nano kernel that I wrote, it would take 19 minutes to boot.
Lol.
Just because it's constantly going, okay, let's load a bit more code. Oops, we need to evict another page. And then It's just constantly thrashing the shit out of a floppy disk. But I think it's once you right, so it's 300. It's about 350 kilobytes. But yeah, basically the reason why you want to run it on a tier 1 stick of RAM is just so you can run a program that is bigger than your RAM on it.
Okay. Alright.
Oh yeah, does anyone know how MMUs tend to work?
No idea.
A bit.
Okay, so the way it works on x86 is you've got two-layer page table. So you've got a page table that points to a page table that points to an address, and it uses the top 10 bits of your address to find the first entry.
Okay.
RISC is usually easier than CISC. Yeah, you got the top 10 bits, and then the next 10 bits are the index into your secondary page table. And yes, and the way that this works on x86, they speed it up by using something called the translation look-aside buffer, which is just a cache of the last few lookups. So there's like, oh yeah, if these top 20 bits of the address match, then we just use this translation. So MIPS is kind of like that, except you take out the page table and you replace it with a fault handler, and you load the TLB manually. It's basically, is this in the TLB? No, it's not. Let's call the fault handler, and then we'll know to load it up.
Good job, me oil.
Did I? Oh, excellent.
Untick me.
I'm lagging really bad.
That one would also work.
Also, my S key is incredibly screwed up. Like you know
stuck?
the rubber bit inside the S key?
Oh.
It's missing, so I replaced it with a little bit of PVC foam.
If I was still motivated, I would have actually tried to put a JVM on this thing.
Oh god.
And then write a sort of mini wrap around LWJGL and get the Minecraft 0.30, no sorry, 0.29_00 something.
Wow.
Files. 0.30 has a check to ensure that you aren't basically tries to ensure that you're running it off the website. 0.29_02 does not, or something like that.
Wow.
And if I'd actually managed to pull that off, then yes, we would have actually managed to beat beat Computercraft fair and square. That we would literally be running Minecraft on Minecraft.
Wow.
That'd be amazing to see. Could you run a Minecraft on a Minecraft on a Minecraft?
Unfortunately, this would be Minecraft Classic, so probably not.
Yeah.
An option though is TC is to actually be able to run it. Would be to have some sort of swap over TCP. That would be quite if you could do swap over TCP, then you would literally be downloading more RAM, but you could actually do that to give the system notably more RAM and actually be able to then you might actually be able to run at least a Minecraft server. Full Minecraft, not Classic.
But you could use creative memory from Vexed Host.
Unfortunately, if you shove creative memory on this, due to the fact that there was nothing actually supporting it, it's nothing. There wasn't a way to look up the RAM values or the size of RAM at the time.
Wow.
It just gives you two. I think it just gives you the size of a tier 3.5 stick, which is 1 meg. Yeah, this is basically the real panel. Yeah, yeah. To be blunt, I think at this stage, I'd rather be helping out Sangar with his OC2 thing, and I'd also rather be writing my own engine to hopefully replace this mess. I have experience with voxel engines, for instance. I was the one who started the Iceball project, and that was pretty much to replace, or sort of like to replace Ace of Spades. And thanks to the nice admins at Build and Shoot, they're still running Ace of Spades 0.75, even though 0.76 exists, and thus that place is now completely fucked. But you know,
yeah.
Admittedly, some of this is my fault because at that stage I'd been adminning for a year, and thus I was really, really intolerant of some people, or certain types of people. So I was trying to make it a little bit tricky. I basically didn't want it to be griefed and shit like that, and so I was sort of like a bit scared, and so just like it was like I had this kick on join variable, and it was set default to true, and the main reason is so that if someone was actually to check that, they could kick people who didn't bother editing their configs.
Huh.
And that was also where I learned that JSON was a complete pain in the ass.
It is.
But yeah, so and the 3D renderer, I sort of did an initial one which was very basic, and then a guy called Melchips did an optimized one that actually used chunks, and that I think it uses 16 by 16. Since then I set myself a challenge to try and write a renderer at 1,000 frames per second, and I succeeded. And that actually abuses geometry shaders. The way it works is you do the chunk selection and on the CPU, and then you do the and then you use the vertex shader, or you use the vertex shaders to determine whether the pointer is frustum. Well, yeah, you do the front chunk selection, so you got frustum cull, and you also cull it into a spherical range. So I'm doing 128 sphere, which is the original Ace of Spades range, and then for each of these, and then for each point, I would do that on the GPU and the vertex shader, and flag it if there was nothing was actually visible. The geometry shader would drop the point. So the geometry shader was responsible for expanding 1 point to 12, forming 3 quads by forming 2 triangles each quad, and then doing n primitive. Yeah, which actually goes completely against what I was told by someone who actually works on the Intel drivers, or used to work on them. He's like, do not ever take a point and expand it to 24. And so I proceeded to take a point and expand it to 24. And yeah, it actually sped things up. He recommended using compute shaders, and so I've got a version that uses compute shaders. That doesn't quite hit 1,000 frames per second.
Wow.
In other words, Intel GPUs are a bit weird.
It seems like it.
Yeah, basically they don't have many cores, but their individual cores are a bit more powerful.
You know the Minecraft client written in Rust, Steven?
Actually, this reminds me. Yes, I did sort of start work on an engine, but this is mostly me trying to get LLVM to behave. I've actually got a plan where I'll use 64-bit block indices, and you'll allocate it. Each mod would allocate chunks of that, up to 48 bits of it, though, because we don't want people eating the whole entire thing. I'm using the LLVMC API. I think at this point I'm probably gonna sort of put that bit to one side while I work on the actual rendering and stuff, and then sort of shift stuff into LLVM bytecode files. Main reason for LLVM. Firstly, I kind of want structs. I think the idea would be like people just write their mods in C and then provide the source, provide the builds, and then or C or C++, but it'll be compatible with C, and then you'd be able to have really, or on Rust, but you'd have a lot of speed. You'd have nice speed because you'd be using structs directly and stuff. But you just know that if you say, oh yeah, just provide a DLL, provide the source, and provide DSO files, some fuck's just going to go like, oh yeah, we're just going to provide the Windows files.
Yeah.
So that's why I'm opting for LLVM bytecode for now. Lua, I could consider, but that doesn't do structs. Yes, in case you're wondering, the actual Iceball game code is written entirely in Lua. There's some I think there's some helper functions and well, there's an interface. The actual the base engine is written in C, and you literally just download Lua off the server. So it's basically Lua that runs in a sandbox. But the improvement that it has over Minetest is that you can actually run stuff on the client. Although that may have changed, I don't know. I'm not that familiar with how Minetest works.
I have no idea how it works.
I know one thing though. If you build Erlich with the default setting, it's going to be it's going to build it in debug mode, and in your Minetest thing will just be painfully slow. So you have to build it in release, or else. 10C CPU. Oh yeah, honestly, MIPS is the easiest CPU to emulate from my experience. It's probably easier than DCPU, just because it's like, or it took me under a day to get the user mode only stuff working, and then I think that even included the hardest bit was probably the LWL, LWR, SWL, SWR things, or R instructions, and they're a little bit tricky to get your head around. But I managed to get. I don't know if I got those working in that under a day section, but that's kind of how you do it. But yeah, and then I found out that the only op I'd fucked up was the NOR instruction. That I think was the only mistake I'd actually done. I don't think I had move from low, move too low and move too high, but yeah. Basically, MIPS, the only thing you need to be wary of is the branch delay slots, and if you actually care about accuracy and you're not worrying about it, and you're not just basically relying on the compiler to cover your ass, the load delay slot. Everything uses the branch delay slot. The load delay slot, however, nothing tends to abuse it because it's fine unless an interrupt happens and then you ends up being inconsistent. So your compiler will usually work around it. And the fun thing is, OCMIPS doesn't actually bother emulating the load delay slot. So yeah.
Well then.
Actually, is anyone familiar with how fuck it, I'm just going to use this as a notepad. So branch delay slot. Wait, let's try this. So, the way that... Oh, hang on, I'll do this one as well. Can anyone guess what T0 will be once you actually jump to dongs? So, basically, the way the branch delay slot is that whenever you jump, the instruction due to the way the pipelining works, the instruction after it also runs before you actually make the jump. So li load load 1 into T0, and these two instructions, they just add 1 to T0. So the instruction after the jump will run, not the one after the one after it. So T0 will be equal to 2. So yeah, this can screw you over. Your assembler usually, whatever assembly you use, if you're using one made by the demo scene, they probably won't reorder it. But GNU assembler, for instance, will actually reorder the opcodes for you. Unless you explicitly say sets no reorder or something like that. Yeah, the lows delay slots, I'll demonstrate it here. Wait, actually, let's do another enter. Wait, hang on. By the way, A is actually short for argument. Yeah, you have like, I think you have 31 registers that you can play with, although they usually got special assignments. This is great when you're actually working with things, but if you need to call an interrupt, or if you need to do an interrupt handler, you gotta push everything.
Yeah.
Yeah. Well, almost everything. You've got to push every single temporary one though. So you assemble a temporary, which you actually have to explicitly say. You actually have to explicitly enable a special mode in the GNU assembler if you're going to use it. Assembler temporary is used for like pseudo ops. So for instance, if you want to say that T0, if you want a branch of T0 is greater than T1, you might do BGT T0 T1 into an address. But what that will actually do is it will do SLT AT T1 letter A letter T T0 T1, and then it will do branch if greater than 0. No, sorry, branch if not equal to 0 or something like that. Or it could do like some. There's several ways of doing it, but some temporary ops will use that AT register that you should never touch unless you're backing things up explicitly. So, the load delay slots. Now, here's the fun thing. So let's say that, let's just say that, let's just start with this. So T0, what would that be? So if loaded's one, are any of you familiar with assembly?
Well, only pick assembly and AVR assembly.
Should be somewhat readable. Load immediates, load word from memory. The reason why you have U after just about every single add or sub instruction is because of you. Alright, it means unsigned, but it's actually it's not sign like you don't have the sign expansion, or you still have the sign expansion. What it actually means is if it does an overflow, so if it goes if the sign bit sort of changes and as it carries over, it will throw an exception. It will actually trap, and if you don't have an exception handler, then it crashes. Thing is, nobody ever actually uses that. They always use the unsigned version. So the load delay slots, the op immediately after a load instruction, so load word, that's the LW T1 0 A0 thing. So T1 is not going to be equal to 3 until after that add happens, so T0 is actually going to be equal to 3 instead of 4. If your however, if your assembler is being nice to you, it will probably insert a NOP in there, and thus that T0 will be. Hang on. No. There we go. So however, if an interrupt happens just after the load word, then when it returns to add you, T1 will actually have 3 in it, so you will end up with T0 equals 4, and that is exactly. And because of that uncertainty, your assembler will work around it. Your compiler will work around it. Yeah. So I'll note the. You probably don't know all the ops, but I'll point out that the MFC. Let me just write this. But yeah, so something to be wary of. If der Index is here, I will point out that that's not water. I don't know who did it. It can crash you if you right-click it with a bucket.
Oh, okay.
So don't right-click it with a bucket, or else you will client crash. I'm surprised the server is still up.
Me too.
Let's.
Survived a lot in the last few hours.
Yeah, I think I could possibly
there you go.
Hello.
Hello, guys.
Hi.
I can't get on the server anymore because joining it crashes my router.
Oh.
Your router?
Ow.
What?
Ow.
Yeah, after a few minutes of being on the server, all of a sudden I lose connection to the router.
Strange.
Yeah, I still can't find where the self-verification. Oh. Hold on. Just found it as soon as I said that.
Main reason this wasn't added to the OC panel was because it was like sort of 4 in the morning or something like that, and there was no fucking way I was going to be up there. And then that's why I wasn't there. So basically, those are the pretty much the two, like, for user mode. If you're just sticking to user mode, those are the only 2 quirks, pretty much. And you usually don't, and you usually, if you're just being slack, you can just ignore the load delay slot ever being a thing, and so you're only worrying about the branch delay slot. One way to do that is to actually have a buffer of the last op read, or and that's what I do. Like 1 or 2 ops read, and you've also, well, actually no, you don't have to worry about which address an exception happened on. But yeah, you track the last few ops and addresses, and that's how you do it accurately. Because otherwise, or reasonably accurately, I'm not completely accurate in this respect. But if you do something like this. Wait, I'm not sure if that will actually. No, that will work if that can. There's a nice pseudo op called LA, which is load address, and it will load 32 bits into a register, and then that will take up either 1 or 2 op slots. Every op slot is 4 bytes. That should be V0. Okay, so fun thing about this. So what this will do... Hang on. That should be, that should really be JAL. There we go. So JAL is jump in link. It will store it in a register called RA, which I think is register number index 31. Register index 0 is always equal to 0. But yeah, so if you do that, what it will do is it will do the first instruction, then it will do the second one, the third one, then it will do the first instruction at eat, then it will move to the first instruction at cry. Unless, of course, there is a jump at eat, in which case it will do the first instruction at cry, and then it will do the jump there. That, I think, is how it works. Yeah. But yeah, basically, if you can work your head around the branch delay slot, that's the easiest part of it done. The easiest part of it done, and you can basically just stick with user mode, and then if it faults, then it faults, and you cry and blue screen and stuff like that.
Well.
Then when you start doing kernel mode, that's when things get kind of tricky, because, like, let's say we have something like this. Load upper immediate is actually a deliberate op. Li, on the other hand, is usually either or I, your thing with the 0 register and your value, or it could be add IU. So you've actually got a range of like minus hex 8000 to positive hex FFFF. Yeah, so let's say we do this. And the tricky part here is that then is working out, okay, which instruction went wrong. And you go with the you would go with the add thing. But let's say that we actually did this. So what actually happens, so in the first case, you will have the exception program counter pointing to that add. In the second case, you'd have the exception program counter pointing to the jump, and then it will actually set a flag telling you that it is actually in the branch delay slot. I think it's marks BD. It's in coprocessor 0. If you want a good document for it, I'll give you a link. 3000.pdf, I believe. It should show up. Oh, no, I don't care about Epson.
Wow.
I don't care about shit. I don't like the thing is I've been using Bing just because Google's been spamming whenever you use it. So
DuckDuckGo.
Or is it R3000A?
Yeah, DuckDuckGo is pretty wild as well.
R3000A. Oh shit! No, it's not R3000A. I'm trying to find the document. Unfortunately, Bing is not being very cooperative at the moment. Wait, there's an R3000. Ah, found it. I'll paste it in Mumble. If you ever want to learn more about the MIPS 1 architecture, that's probably one of the best documents on it. It's a lot nicer than the stuff they have on the MIPS 3 architecture, which is basically when the guys who made MIPS got really professional and stuff, and it's not as nice to read. But the first one, it gets very casual at some. It's got this really sort of really relaxed tone of voice when you're reading it. I'll read out some classics. Okay, so I've got my PDF reader up. Fun thing, I did manage to get the video decoding working on MIPS, but it's kind of like not much point. And also, I think I've completely shot the timing now, so it's probably. I think it really only does like. I think the ticks really only work. It ends up doing 10 ticks a second or something like that, just because my timing is completely shot. But yeah, oh yeah, the assembler language programming section, where it's hexadecimal constants, numbers preceded by 0x or 0 capital X. Octal constants must be preceded by 0. Be careful not to put a redundant 0 on the front of a decimal constant. Constants are, and then it's got like just a 0 on its own, and the comment says strictly octal 0, but who cares?
Wow.
That as casual as it gets. I'm trying to find. There's another goodie with the. Oh shit! Where was this? I don't know if this one has the. I'll give you an example of the slightly more serious aspect of the tone of going through the voice. Notes the li load immediate instruction, which again isn't found in the machine's instruction set. Li is a heavily used macro instruction which loads a 32-bit integer value into a register without the programmer having to worry about how it gets there. It's just got this really nice tone of voice. Yes. The jump instruction. J. This instruction, jump, transfers control unconditionally to an absolute address. Actually, J doesn't quite manage a 32-bit address. The top 4 address bits of the target are not defined by the instruction, and the top 4 bits of the current program counter value is used instead. Most of the time this doesn't matter. 28-bit still gives a maximum code size of 256 megs. It can be argued that it is useful in system software because it avoids changing the top 3 address bits, which select the address segments described earlier in this manual. To reach a really long way away, use the JR, jump to register instruction, which is also used for computer jumps. That is probably the best PDF to read about this architecture. It does have lots of big words, but it's got a really nice tone of voice.
Wow.
Seems to.
Yeah. I don't know who actually originally wrote it, but if I have it right, so this is IDT's. IDT. I don't know where they're located. I keep thinking that they're originally located in Scotland or something like that. But yeah, basically, if there's any, I think there is there's more than one mistake, of course, but one that was particularly annoying was the cache management thing. There's a good when it it's memory management in the TLB. No, I think it's the thing about coprocessors 0, which is where all the really fun system stuff happens, and where it's just lots and lots of fun to try and work out how to emulate the damn thing. Yeah, that's where MIPS gets kind of hard, but you can still get it working in a quicker time than it does to get even just ARM user mode, but not by much.
Oh.
Let's find this damn thing. Never mind. There is a CP Naught. Wait, that's CP Naught instruction reference. Operation reference. System control coprocessor architecture. There we go. So this is something when I was trying to port Linux. There's a flag that shows up. CM shows the result of the last load operation performed with the D cache isolated. The CM is set if the cache really contained data for the addressed memory location, i.e. if the load would have hit in the cache even if the cache had not been isolated. This is wrong. It's clear because CM, they never actually expand on what it's short for. It's short for cache miss. So that is actually a mistake. That. But yeah, this another good source of another source of good reads is where is it? There's the Usenet archive, and basically anything about MIPS or anything by John Massey is a good read. And I will link that in Mumble as well.
Okay.
I have no idea how much of this you guys are following, but like I can continue looking for some gems from this.
Sadly, I have no idea what any of this is, but I'm trying to understand.
That's alright. Yeah, where is it? I've got a feeling the part of this tone of voice, if the bulk of this is written by anyone who actually worked on maps, it's probably they may have got John Massey to do it, or some of it. Where is it? There was something that I almost think may have been a dig at x86 and 68K about interrupts. Although I think John Massey points on this out, and there's Usenet postings anyway. Where is it? It's where is it? Oh yeah, there's a fun thing. There's two registers, K0 and K1. Don't ever touch them because they will get clobbered at every single interrupt. The K0 and K1 are just so that you can clobber them during your interrupts. Unless of course you want to determine whether an interrupt is fired or not, but that's not really recommended. Where is it? I think it actually does do a dig. I'm trying to remember where it mentions like others. It says something about other here we go. Unlike most CISC processors, the MIPS CPU does no part of the job of dispatching exceptions to specialist routines to deal with individual conditions. That is, they don't have a massive table of addresses for every single different exception or every single different interrupt. The rationale for this is twofold. On CISC CPU, okay, so the second one is on a RISC CPU, ordinary code is fast enough to be used in preference to microcoded. But yeah, on a CISC CPU, this feature is not so useful in practice as one might hope. For example, most interrupts are likely to share code for saving registers, and it is common for CISC microcode to spend time dispatching to different interrupt entry points where system software loads a code number and jumps back to a common handler. No shit, this actually happens. You're literally like on x86. You are literally you got to your IDT and you generally don't point them to the same thing. You point them to different things which just set a code and then go to a common handler. I am not making this up. This is how I have done stuff myself. 68K. I don't think I've really done that many interrupts, but if you're doing any system software, that's probably what you'll be doing as well. Yes, MIPS work. Wait, hang on. Where is companion cube in game?
No.
I don't think so. I think his PC is not good enough.
Yeah, Linux nearly worked. Okay, what are your... Alright, I should probably ask you guys, what sort of level of programming do you guys do at this stage?
It's honest truth. Apologize. I don't know anything about coding.
Okay. Right.
Well, I started coding with AVRs and C, and then I moved on to PC C stuff, and then Java and Rust, and currently I'm in love with Rust. Oh.
I can understand that. It's kind of like it's all. I need to try it out sometime. It's almost like, hey, we're going to do sort of memory safety the C way, and C is glorious. Yeah, C is the only language you will ever need. Well, that's sort of how I say it. It's not entirely true, but it is a great language. I much prefer it over C++. I don't like C++. I'm of the view that C++ is a candy shop of bad decisions. I mean, ultimately, you've got all these tools, but some of them might improve things. Most of them are just like, oh, let's try using this, and it makes a mess of something. Or basically me. Yeah, and basically that's I do like Linus's rationale for using C for Linux and for Git. It's ultimately a data-heavy operation, and so anything like C++ provides he's got twofold rationale for using C and not C++. So C++ provides C++ provides only a very small amount of things that are actually useful. And the work required to just write in C is not really enough is not actually too much, so you might as well just do it in C anyway, instead of having to deal with C++ does have a tendency to have bad compile times. Okay. But the second rationale is that it filters out the bad programmers, because there are people like, oh yes, I'm gonna pull out my C++, I'm gonna pull out my objects, I'm gonna make a game, I'm gonna have a chunk class, and the chunk class is gonna have block class, and the block class is gonna be made up of triangle classes, and then I'm gonna do chunk.draw, and it's gonna go, block.draw,
concurrent modification exception.
Oh, that too, but yeah, triangle.draw. If you've ever seen anything by Mike Acton, he rips the shit out of anyone who does that, or he rips the shit out of any code that does that, just because of the level of indirection. I'll point it out on here. If you do that, your code's going to suffer, because so world, is an indirection. Okay, so we've got pointers to the world. Chunk, that's another indirection. Like if you've got an array of pointers to chunks. In Java, that is literally what you've got. You've got pointers to chunks. You never have an array of just chunks all nicely lined up. So yeah, you have your array of pointers to chunks. So you draw on that, then array of pointers to blocks, then an array of pointers to triangles, and you basically every single triangle ends up going through. I think these first two might actually even out a little bit. Well, the first one, the world to chunk thing, there's not going to be that much direction there. But I think if you do block to triangle though, well, it would be block to quad because OpenGL provides quads. But there's a lot of so there's sort of three triangles that get indirected there, and then every block gets an indirection. So you've got 4 indirections times the number of blocks in your chunk, and then plus 1 times the number of chunks, or something like that. And all this indirection is just really bad for your cache. Oh yeah, World Manager, yeah. I think once you get up to chunk, if you do actually have a pointer to each chunk, that's kind of justifiable. But then once you get to the chunk, you just want to have every block and just in a block as a struct, and have that in an array or something like that. Yeah, so I probably completely lost all the non-programmers here. I'm not sure how many people here write mods. I only half count because this is a mod for OC.
I do. Well, technically I also only have a OC add-on, but yeah.
What add-on do you do?
Open radio laser stuff and probably later on satellite communication, but I'm not finished with that.
Open radio. You actually make blocks. I just write an architecture that hangs straight off the core thing.
Well, the functional stuff of my mod is like really small, and fiddling with Minecraft code, like rendering stuff that it actually renders correctly, is a pain.
Despite being one of the most vocal people here, I do not have any mods, and I'm not particularly familiar with programming.
Yeah, I generally just write code. I generally just write code for not Minecraft. It's pretty much to sum it up. But
it's better if you want to stay sane and stuff.
Yeah, something I'm reminded of. Yeah, a nice thing about MIPS. About using a nice thing about OC MIPS and Advanced. The main disadvantage that OC MIPS has is that there's fuck all software for it. And to actually write your own software, you've got to set up a GCC cross compiler, which pretty much rules out anyone running Windows. But yeah, what's it? So the nice thing with I'm running Void. Void is great. Void is a great Linux distro. It is honestly the only it is the one distro that you should use pretty much. Basically, one of my conditions is no system D. That rules most things out. Debian, I think you can cut. I ran Crux on my laptop. It just sort of think it's got BSD in it.
Quick question: why don't you like systemd? Like an argumentation?
I had to try and disable something. The documentation's a pile of shit. And furthermore, now it's just like, it's getting harder and harder to not use it, and I'm like, I'm actually going to have to make a very good point of doing what I can to make sure that there is always a choice.
Mm.
And that choice is probably going to involve telling people to use cinnamon and not gnome. I used cinnamon in a... Oh, actually, fun thing. So, installing Void. There's really only one issue with the installer. If you partition your disk, and then you have to go back and partition it, you'll screw up the installer, and you have to close the installer and start it again. I think that's the only issue I've had. That, and also its rolling release, and during running it, the only package issue I've had was one of the versions of NSS broke, so I had to roll it back, and then suddenly, then like the next day, they'd rolled it back on XBPS, which is their package manager. Yeah, and when I installed Ubuntu in a VM just to sort of test it out. And yep, that still has issues. That still has weird issues. That one I didn't rip systemd out of it because I just kind of need it reasonably vanilla, just sort of testing things around. So it's not something I hear about often.
Sounds like you have had a relatively painless time with Void.
Yeah. Have you had pain with Void?
What now?
Have you had pain with Void?
Nope.
I've had pain with Crux. Crux is... Yeah. So... Now alright, so imagine Gentoo. Now imagine BSD in it instead of OpenRC, which is still good. Imagine... Like, I like BSD in it, actually. The Void users run it, sort of okay with it. I've used... If OpenRC actually ends up reinventing some of the few good things that systemd does, like socket activation is apparently a good thing, because it means that you can literally just start everything very, very, very quickly, and then the dependencies only fire up once the sockets are in place. Yeah. It is something like that. You basically start... You open a socket... No, I think it's like you start a process which opens a socket. You basically just start every single process at once, and they once they open a particular socket, that means that they can something like that. There's a distro I'd like to try at some stage, but unfortunately I think the downloads have disappeared. It's called Damn Vulnerable Linux. It is very much for research purposes, basically.
It does still exist.
Was it?
It does exist, yeah. I don't know if it's still updated, but it does exist, and it's really vulnerable.
I couldn't find the download for it.
Hacking Lab still has one. I would have to search a link for it. 1 second.
Okay. What's it, Oh, what the hell was it? Oh yeah, I was explaining Crux. So you sort of you think again to think it's got except different init system. It's got different package manager, which is actually pretty cool. But then there's fuck all packages. There are lots of packages that are missing, and some packages actually break. But Crux is pretty much the ultimate Crux is pretty much the ultimate distro for people who absolutely hate Linux tutoring with a passion. So if you absolutely want to completely avoid absolutely everything to do with Linux, use it. I mean, you can install Pulse, but the one thing it does do better than Void though, so Void's got an OSS Pulse wrapper. Crux uses one which wraps it to ULSA. And so I've actually managed to install that from GitHub, compiled it and stuff, and that was so I could get Skype working. Fun thing, Skype, when I was running it on Crux, didn't work. It seems to work on Void though.
Why would you want Skype?
Yeah, why would you want Skype?
Because some people haven't fucking heard of like
Discord, Mumble,
or even Discord would be better.
I like Discord a lot. I actually have a little group myself on Discord.
The only thing I like
great,
about
Tox
this
is great, Discord's okay. Yeah. Skype can go fuck itself.
Exactly. It's a bit like the Skype protocol was shit, and the Skype Linux client that exists that wasn't updated since Microsoft bought Skype still works, so the protocol still has to be shit.
The original one, the Skype, the old client for the old Linux Skype client was great. 2.1, 2.2 or something like that. Because that was that one you could actually do s/something/something/, and you could actually edit your last image your last line by that. But honestly, fuck them so much for blocking it out. Because when I was running FreeBSD, I had I think I could still run that, maybe. And then suddenly it's just like, oh no, sorry, we're shutting down this thing. Sorry, because we're wankers. Actually, who here has used Tox?
Me.
Yeah. Oh yeah, I think I use Qtox for my client. Well, I used to when I was using
CLI client.
Alright. Qtox did actually. Well, we confirmed that I confirmed with ASU that video calls did work because he was showing me a bunch of shit.
I never tried video calls, but audio calls did work. I tried those.
And if you're wondering what he looks like, he looks Polish.
Wow.
Which doesn't narrow it down. So that's great. Actually, speaking of people who I know the looks of, remember one time, was at a LAN party at our university. Held by the engineering group, of course. And so I was running a game of Space Station 13. I was running the Space Station 13 server, and I asked, I think it's like sort of announced that we were doing a game, and it's on Beyond. And then I was sort of seeing an OOC, probably about 10 minutes in, seeing an OOC chat, this familiar name called Imibus. So yeah, we've actually have met IRL.
Wow.
Oh.
Yeah. In person, he... Yeah. I don't know. In person, he can sometimes come across as a bit grumpy, but yeah.
This water is ridiculous. It's been growing. So someone's flooding the area.
Wow.
Yes, the Amibus, he lives in the same city as I do. And we were at university at the same time at some point. He was talking about, this is prior to me having any experience with ARM, but he'd actually mentioned he'd done stuff on either the GBA or the DS in ARM assembly. I don't know exactly what he's done though. There. Damn it! This is the frustrating thing. The people who are just causing the most. Alright, so I have this bow, and I've got hallucination arrows, and the people who cause the most shit are usually people in creative mode, and thus not affected by hallucination arrows. Actually,
wow.
But come to think of it, this unfortunately has collateral damage, but what's the strengths I've got? I don't want lingering. The shortest period is 3 minutes.
What portion is this?
Hallucination.
It is not work.
You said?
Shit. Hallucination. Hallucination's the best. Oh, hallucination's a great potion. Well, it's even better. I like it in arrow form though, just so that you can aim it more accurately. Oh, is it?
Oh.
Yeah, I know. Didn't you notice this when trying the hallucination?
Damn it, someone gave me invisibility. Why can I still see people though?
Because you're in creative.
But I can see people too.
I see dead people.
Ba, ba, ba.
Same, every day. They're everywhere.
Speaking of every day, hang on. No, that doesn't have the shape driver.
Some of the shaders from the